Hello, I'm Dr. M. Suguna, working as a professor in Siddhartha Institute of Science and Technology. In this video, I have to discuss about derivation of Nernst equation, representation of a galvanic cell, determination of standard electrode potential of a galvanic cell, etc. So, in previous video, all these things are explained by me. What is redox chemical reaction, electrode potential, and how to generate electrode potential between an electrode and electrolytic solution, holds electrical double layer, etc. things. So what is meant by standard electrode potential? Standard electrode potential may be represented by E0. The potential measured at standard conditions is called standard electrode potential. Standard conditions are temperature is 25 degrees centigrade or 298 Kelvin temperature, 1 atmospheric pressure, and unimolar concentration of an electrolyte. A galvanic cell, already you know about that. Galvanic cell is a combination of two half cells. One half cell acts as anode, that means the electrode material is involved in oxidation. Another half cell is called cathode. So cathodic material always involved in reduction. The tendency of an electrode to lose or gain of electrons when it is kept in contact with its own aqueous salt solution is nothing but electrode potential. The potential created due to the oxidation is called oxidation potential. The potential created due to the reduction is called reduction potential. So generally, the standard electrode potential of a galvanic cell may be represented by E0 cell is equals to right hand side electrode potential minus left hand side electrode potential. Right hand side electrode is called cathode. That means cathode potential minus anode potential. So always standard electrode potential may be represented by standard reduction potential. So generally standard reduction potential values of different electrodes are mentioned in a table that is called electrochemical series. Electrochemical series is the arrangement of elements increasing or decreasing order of their standard reduction potential values. So this electrochemical series is very useful for the determination of electrode potentials of different electrodes. Electrode potential may be determined by using Nernst equation. Nernst equation is a mathematical representation which gives information about the electrode potential and standard electrode potential, which explains about the relation between electrode potential value E and standard electrode potential value. So the Nernst equation determined by using a general redox chemical reaction. So let us assume this is the general redox chemical reaction represented by M n plus n number of electrons gives rise to capital M. Mn plus means a metal carries n number of positive charges, requires n number of electrons for reduction. It will reduce us into metal. So this is the general representation of a redox chemical reaction. It is a reversible reaction. For such redox reversible reaction, free energy change, Gibbs free energy change is delta G. That means Gibbs free energy change means the energy of products minus reactant. This value is always negative. That means the decrease in change in Gibbs free energy is converted into work function. According to Einstein equation, energy Energy does not created or destroyed. One form of energy is converted into another form. So here also the decrease in energy is converted into work. And standard Gibbs free energy is denoted by delta G naught. So this is measured at standard condition. The equilibrium constant K, having the relation according to the want half equation. Want half equation is delta G equals to delta G naught plus R3 ln K. This is a well-known want half reaction. Explains about the relationship between delta G naught, equilibrium constant K, etc. Here R is the universal gas constant that equals to 8.314 joule per mole per Kelvin, or 8.314 into 10 to the power of minus 7 Ergs per mole per Kelvin. T is the absolute temperature, that is room temperature 25 degrees centigrade or 298 Kelvin. K is determined by using law of mass action. According to law of mass action, equilibrium constant K is equals to the ratio between the concentration of products divided by the product of concentration of the reactants. So delta G is equals to delta G naught plus RT ln concentration of products divided by concentration of reactants. But delta G is equals to minus N into F into E. So delta G is the product of number of electrons involved in oxidation or reduction. That means number of electrons involved in losing or gaining process. F is 1 Faraday. 1 Faraday equals to 96,100 coulombs. E is equals to electrode potential. Delta G naught is equals to minus N into E naught into F, where E naught equals to standard electrode potential. By substituting delta G naught and K values in this equation, we get minus N into E into F is equals to minus N into E naught into F plus RT ln K. Here K is equals to, for general redox chemical reaction, M is the product, Mn plus is the reactant. So NF is the common term. By cancelling N F on both sides, we get E equals to E0 minus RT by NF into Ln metal concentration by electrolyte concentration. So E equals to E0 plus, by substituting R value, P value, F value in this equation, R 8.314 into 298 Kelvin by 96,500, we get 0.0591 by N into ln 1 by X is equals to minus ln X. Like that, ln metal concentration is always 1 by 1 by Mn plus. So ln 1 by Mn plus is equals to minus ln Mn plus. So minus into minus plus, E equals to E0 plus 0.0591 by N into ln Mn plus, where Mn plus concentration is equals to the electrolyte concentration. So last equation for a galvanic cell made with zinc and copper electrodes. So this is the net cell reaction. Galvanic cell made with zinc and copper electrodes. Zinc acts as always anode and copper acts as cathode. How this galvanic cell representing in mathematical form? What's the representation of this galvanic cell? How we can express this galvanic cell? Always left hand side electrode acts as anode and right hand side electrode acts as cathode. Already known about it. So anode may be written on left hand side, cathode may be written on right hand side. Anode can be written by writing metal first. So here zinc is the metal, it is exist in solid state. So phase of the metal is represented in brackets. Then the electrolyte. So we have to write a short form of electrolyte or full form of electrolyte also. Here electrolyte is ZnSO4. Zinc metallic rod is immersed in ZnSO4. So zinc is the metal, ZnSO4 is an electrolyte. So writing a metal first and then electrolyte. Electrolyte concentration may be represented in bracket, that is C1 molar. So electrode and electrolyte are separated by a vertical line having negative sign. This is anode. Next cathode. Cathode may be written on right hand side. Cathode may be represented by writing the electrolyte first, then electrode. Both are separated by a vertical line. And concentration of the cathodic solution represented in bracket C2. Anode and cathode are separated by two vertical lines. Two vertical lines denotes U-shaped glass tube that is called salt collection. So this is the representation of a galvanic cell. So non-stick, the final form of non-stick equation E equals to 0 minus 0.0591 by N into Ln product by reactant concentration. Product concentration by reactant concentration. So in this cell reaction, products are Zn2 plus and copper. Reactants are Zn and cupric ions. Already we know about metal concentration is unity. Concentration of Cu is equals to concentration of Zn, that equals to 1. So E equals to V0 minus RT by NF into Ln products Zn2 plus concentration into Cu concentration divided by Zn concentration into Cu2 plus concentration. But the concentration of Cu equals to concentration of Zn equals to 1. The remaining equation equals to E equals to 0 minus 0.0591 1 by N into Ln Zn2 plus by Cu. This is the final Nernst equation for the galvanic cell is constructed by using zinc and copper electrodes. Thank you.